how to design something under uncertainties. I think this is a big differential of our students. We wanted the lightest wing that would produce that deformation, and then it would still sustain the flight loads. But I felt, wow, I'm just teaching now. I felt a bit stuck. I don't want to sell. Of course, I'm biased towards Embraer, but I know their culture is quite strong in that sense. And I was at the same time a bit scared that I had just finished my master's and I was still not able to comprehend everything that I thought I knew. Be useful in industry, let's say, and they go and do a master's, The first 3 months of my PhD, they were hell, literally hell.
Hello everyone, welcome to the Aerospace Show. Today we have the privilege of sitting down with one of our professors and TU Delft's lead researchers, Saullo Castro.
Professor Castro has more than 10 years of industry experience being a production design engineer at Embraer and now leads academic research into structures and computational mechanics here at the TU Delft.
If you want more aerospace related content, please be sure to check out aerovia.org.
Enjoy.
Thank you for being with us, Professor Castro. You started with a bachelor in materials engineering, and now you're here at the Faculty of Aerospace Engineering. Was aerospace, or aeronautics to be more exact, always the plan, or what prompted the switch?
Yeah, I can say when I started my bachelor's, that was never the plan. So I was passionate about engineering. When I started my engineering course in 2001, I already had a technical diploma, let's say. At the time it was called like data processing, what would be now informatics or computer science, let's say. So I was like at the technical level in computer science. So I always loved to program, but then I wanted to go and do engineering. Then I started materials engineering, which is a lot of physics, also chemistry, but in my course with a high focus on mechanics. So I always loved the mechanics part of my course, so how to calculate structures and structural members. And towards the end of my bachelor's, I think I was in the 3rd, 4th year, and then I heard about Embraer. And Embraer, they have this engineering training program. It's quite well known in Brazil, but to get accepted there, it's quite competitive. To give an example, we had 4,500 candidates for 180 positions only. So it was quite immense. Yeah. And they have an online exam for English, and then an online exam for technical content. And then after all the selection steps, I started my traineeship at Embraer. And then I got passionate about aerospace, but especially the engineering challenge of working in a multidisciplinary design. This is what really attracted me, I think.
Okay.
Yeah.
And looking back now, having all the experience and all the knowledge you have, what advice would you give yourself just starting out, as you're describing right now?
Yeah, I think I would give the advice that I tried to follow when I was in my bachelor. So trust your discipline more than your motivation, let's say. If you're not motivated to study, but if you have something in mind, some goal to follow, to pursue, just have discipline to pursue that. And then the motivation usually comes after you kind of offer yourself that discipline. I think that's the advice I would give to myself. Like, be even more disciplined and try to study more and learn all the topics that you can during this time, because that's probably the only time you can really, really focus on studying the basics. Because after that, in the master's, also at the company, and after doing my PhD and so on, it is kind of assumed that you have those basics already. And if you don't, you spend quite some time filling in the gaps. So I think the most advice would be, when you get in touch with something new in the bachelor's, even if you don't yet understand how you can use that, but be humble and study that, try to learn. That would be the feedback I would give to myself. Yeah.
When you started your career in academia or materials engineering and that process to getting the trainee place in Embraer, what was your main idea? Okay, I'm doing this degree for what?
I don't know if I had all this perspective at the time, but I just wanted to learn. I had this, after, I don't know, I was 19 years old, I really had this passion to learn things. And I was just like looking for opportunities where I could learn more. And I was never looking for higher salaries. Despite, I must say, Embraer, they were one of the highest paying companies because it's aerospace. but I was more for where can I learn more. So that was the driver for me to choose my next opportunity. I think I did not really have in plan like a good plan of what I wanted to be in 5-10 years, but I just had in mind I need to learn a lot. So then I was always trying to take opportunities that would, let's say, give to me this chance of learning more. So that was really my driver, I think, at the time.
And could you describe your path through bachelor's, then to the PhD eventually? What was the road like? You went materials engineering, then you ended up PhD.
Yeah, so I can explain. So in Brazil, the bachelor's is usually 5 years in engineering, and most of the people doing the bachelor's in engineering, they are not aiming to continue in a master's. So their main goal is I will finish my bachelor's. The vast majority, they would finish their bachelor's and already start working in industry. Mm-hmm. And even when I was going to finish my bachelor's, some people were considering doing the master's. And the perception I had at the time of people doing the master's, these are people that cannot find a job, So it was I had a very negative impression of research in general. Yeah. And my impression was always, okay, these people cannot be useful in industry, let's say, and they go and do a master's, For me, it was, I saw a lot of research, what we call like going to the shelf after they're finished and they're never used. Yeah. I really had a bad impression about research in general. I recognize that here we are different than that. Yeah. I really recognize that. I think in Brazil it can be really theoretical and really useless sometimes. Yeah. And so just to say, then I started, when I started after my bachelor's doing the internship, it was in a steel company in Brazil, And then funny enough, it was in the research department of that company. Uh-huh. And then I think is when I learned more applied research, that research that can be used directly in practice and how much benefit you can get out of it, Then I started to believe more in, actually I can do research that is directly useful. And then at Embraer, when I started the traineeship there was also the opportunity to do a master's in aerospace engineering by the Aeronautics Institute of Technology. It's known as ITA in Brazil. It's very well known. And then I decided to do that, to try that. And then I worked in optimization of composite wings with buckling constraints and stress constraints. After I did my master's, that was in 2009. I went to a conference in Barcelona. Mm-hmm. It was a conference in optimization in general. And at that conference, most of the people attending the conference, they were PhDs. Mm-hmm. And then I was fascinated by the level of depth of the discussions that they were having. And I was at the same time a bit scared that I had just finished my master's and I was still not able to comprehend everything that I thought I knew. That humbled me a lot, So I said, actually, despite I'm master's in engineering, I don't feel like that, So I really need to learn more. How are these methods really developed? Many methods that I used in my own master's, I wanted to know more. How are they really developed? What are the details I would need to learn to understand them, to improve them? And then that's what drove me that really fascinated me. And then I started immediately after I came back from the conference to study English, because everything so far had been done almost only in Portuguese. Even my master's thesis, even the conference I went in Barcelona, it was bilingual, Portuguese, Spanish. So I could speak in Portuguese. But then I decided, no, I need to learn English. And I was trying to do a PhD. I was first trying at University of Florida in a group of Professor Haftka. He's really well known. He was also the supervisor of Professor Gurdau, who was one of the professors here in Delft, which was one of the supervisors of Professor Mustafa Abdallah, who was also another professor in Delft. And so I was trying to get to his group in Florida. But during this time, I was studying, doing the TOEFL exams, all this. Mm-hmm. It was 2009, 10. I got in 2011, I got a confirmation from another opportunity that I tried in Germany from DLR, so a project coordinated by DLR, that they would pay my scholarship to do the PhD. So then I decided to go for that. So and then I began the PhD. I finished my master's in 2009. Yeah. It took me 2 years to get the English studying that I needed,
Mm-hmm.
and to get accepted to a PhD program in 2011. And during this time, I was, of course, working at Embraer as a product development engineer, learning a lot on other things, of course. But then in 2012, I was offered this opportunity to start a PhD in 2012. And then it was sponsored by DLR and also by Embraer. They wanted me back, so they kept my salary
Nice.
Okay.
to not the full salary, but to a good level, let's say, then with the condition that I would work there after the PhD.
You say in the conference that you looked at these PhD people like, whoa, okay, they know so much. You already have worked in the industry like before this event for a while, a few years at least. And what, because it's a really interesting discussion how some people think, oh, academia is for a certain type of people. I want to go get my hands dirty in the industry. What advantages do you think you had over them as work in the industry well?
Yeah, I think definitely on the practical use of things, on finding the right examples for different applications. I think a bit bridging the link of purely theoretical approaches to where can this be really used in practice, and what would be the impact of this technology in practice. That's a skill I have still, and I think it's something different than the average academic, let's say, because most of them, they don't have so much experience in industry. And so that's something I carry with me, that of these many years, more than 12 years in industry, I carry this with me, I think, for the whole career now, that this perspective of practical use and how much impact the technologies would have in the real practice, and in our case for aerospace is mostly how much impact would the technologies have in certification, how much can they really affect your product at the end. So at the same time it's good, but at the same time it's a bit bad, because you tend to disbelieve extraordinary disruptive ideas, because you say, okay, this would cost so much in terms of implementing the idea and changing the whole manufacturing and certification, that you tend to be a bit more skeptical. But that's I think that's me, So I'm always a bit more conservative, a bit more skeptical. That's, I think, how I also approach my research.
And was that when you started your PhD, was that a challenge for you, reconciling the industry experience and now having to be very academic focused?
Yes, I think so. It was a challenge. I remember the first 3 months of my PhD. They were hell, literally hell, because I had to read more than 200 scientific papers, I think, that I read to some extent over like full-time 3 months, more or less, to get an idea of what would I do, that is relevant, that had never been done before, and that I could do with my own skills, and that was hell, I think, to really find the research questions that I had to address during my PhD. But I think because also I had to mentally move a very long way from my industry with him to the research with him. That took a little bit of time, I would say. I was asking myself, what am I doing here?
Yeah.
Many times in Germany, what am I doing here in my PhD? I should have stayed in industry. I was there. I was already delivering, producing nice things, and now I'm here studying for nothing. That mindset was haunting me for a few months.
And that's, well, eventually, amongst most PhDs, that's a quite common barrier to kind of crash into. Are there any other challenges? And then what advice would you give PhDs currently with your given experience?
I think that's indeed a very common thing, not only for the PhDs. Even, I would say, I would include the master students there as well. In the first month for the PhD, but also in the first weeks for the master students, they have to handle that, finding exactly what they're going to do. And it can be very demotivating. I think what helps, again, is discipline. If you're demotivated, trying to establish a rhythm, So, okay, I will work from 9 to 5. After that, I'm free to do whatever I want, but I will commit myself to trying and working from 9 to 5. That helps a lot. What also helps a lot, I think, especially for the younger generations, I think you are quite bombarded with dopamine, short form content. We were discussing earlier. I don't have a TikTok account, but I know they're really short formats, right?
Yeah.
And if you're used to these quick dopamine releases, from short videos, imagine if you stay the whole weekend watching TikTok and watching series. And then on Monday morning at 9, you need to start reading literature study.
Yeah, it's
How come you'll be motivated? I think that's the challenge. So you need to really believe that you need to do that first, and you really need to put aside your phone and all this. And I think your habits over the weekend, they will affect you. Especially on Monday, let's say, Monday morning and Tuesday, I think you are highly affected by what you're doing over the weekend. I think this is a challenge for the youngest generation to keep an eye on, let's say.
Okay. Well, you're saying that especially because, I don't know, I imagine yourself in your position, struggling so much when you started your PhD.
Yeah.
Because when you were in the industry, okay, I have this idea, you show it to your supervisor. Oh, okay, in a few months it's already being produced.
Yes, yeah.
And the PhD, the stuff you're investigating, it may never come to real life.
Yeah, that's the common, actually. That's the norm even. That's true. It's very hard to convince yourself that's why it took me a few months that what you're doing is anyhow relevant.
Yeah.
Because indeed, in industry, at the time I was a mid-level product development engineer. So I was able to deliver solutions very quickly. And the solutions can be anything you imagine in terms of structures. It can be a new design, it can be an optimized design, it can be even when we're assisting production, like how to set up this equipment to fix the engine into the wings, how to set up the preloads that you need to set up correctly, and even these kind of things that we do in industry. And I was a specialist in optimization, sizing optimization especially. So it was quite nice, I had a very nice network. I was one of the technical references for this. And then suddenly you become, like how I saw myself at the beginning of the PhD, nobody,
Yeah.
And then nobody working into something I could not yet believe,
Yeah.
So I think the motivation does not exist to the level.
PhDs?
No, I think at the beginning there is a risk. The motivation that you wanted does not exist yet. So you need to cross this valley of low motivation with some other aspect. And that other aspect, I think it should be really putting effort and discipline. And I think a routine helps with that.
Yeah.
Also sports, I must say, they really help.
Okay.
If you have a strong body and usually your mind is better, let's say.
Okay.
Do you play any sports?
Yes, I do.
Yeah?
I used to run a lot,
Okay.
but now I'm more trying to gain weight, really, just become stronger and gain weight.
All right.
Because I was really thin at some time. I was 72,
Okay.
so it was really thin for my height, and I'm 186 centimeters.
Okay.
And now I'm 94, but my goal is to go to 100 kilos. Let's see if I can
Okay.
achieve that.
It's a quite common thing to hear, especially from people who are really involved in their work, that the physical, being able to release and escape from the everyday helps. And I know it helps me with my studies. I go to the gym and stuff like that.
That's my advice for every student. Make sure you're up to date with your, that you're fit. You don't need to be strong, but you can just run. But make sure you're fit, because that helps you a lot with concentrating and with everything else.
Right.
Because then you eat properly, you sleep properly, you don't waste time with TikTok, Netflix, so you focus on the important things.
Well, it's a huge contrast because I guess it was the same in your university in Brazil, where I come from. Universities don't give a really big focus into athletics. And here, huge sports center, American universities, they have all the sports in the world. So it's pretty interesting. How do you think it's something that's overlooked sometimes?
Yes, many times I think. Yeah, it's many times overlooked. I think, I don't see that. Despite we have the sports center here, but it's not a part of your program, right?
It's not obligatory.
Yeah, exactly. So perhaps it should be.
Okay.
Yeah, I know your agendas are quite full, but I think there should be time enough for you to practice sports. And if we don't provide that, you should find out how to do that. Yeah, at least we have the infrastructure. I think that helps a lot already.
All right.
And you've spoken a few times now about your role at Embraer as a product development engineer. Could you go a little bit more in depth as to what that entails? Yeah.
So when I started, it was secondary structure, sandwich panels, galleys. That means these structures, they are not part of the primary load carriers of the airplane, so they are not necessary for the integrity of the primary structures, or for example, to keep the wing where it is, to keep the tail where it is. But these structures, they're more related to the cabin. and safety of the passengers. So there are sandwich panels like the galleys I mentioned. We have also monolithic composite structures for the overhead bins, and they carry a lot of load. We have the seats; they're also part of this, and the floor panels, the floor sandwich panels. These are the main structures I was analyzing. And at the beginning, when you start, usually you're checking reports. You're not producing reports. Then I was checking reports for 6 months to 1 year. And then in the second semester, let's say, I was already partially creating reports and also checking reports. And then I was more creating reports after the first year. And then my tendency was always to work on the methodologies. And then after the second year, I was already working on methodologies on how to improve our stress analysis processes. In that case, we created an envelope methodology. For example, when you have a new customer, they can change the interior configuration. So which galleys do I want, or which monuments do I want? One of them is the galley, but you can have other things. You can have a lavatory, can have many other things, many other combinations, but they will produce different loads. And then for every new configuration, you need to check if that's covered by the previous ones that you have certified. So I created a methodology to envelope and to simplify the analysis by a lot. That was great, but that required a lot of programming, a lot of data management and things like that. Yeah.
In our last interview with Alderlisten, Professor Alderlisten, check it out. He talked about how one of the main things in implementing these new technologies or the fruits of research in real life is with regulations with people. How's your experience with that?
That's okay. I can give an example more of what happened in industry. So after my PhD, I was working in basically revolutionizing the stress analysis methods within Embraer. Not all of them, but there was one major for fuselage and another major for fatigue, and another major for it was fuselage fatigue, and was random fatigue analysis basically. And you have to, despite the technical skills you need, these let's say, you can take it for granted. Everyone would assume that you're really, really high on the technical skills. For everyone, that's true. But then there is a second aspect, which is the political aspect.
Yes.
So you need to not only say to your colleagues, "Oh, I'm the best. I have the best methodology. Therefore, you should use it." That's not how it works at all. So there was a lot of effort in explaining the methodology to other people, and making sure that they fully understand it, and not the low clerical people, let's say, but the senior people, the senior engineers, and there is a level of seniority where they are direct in contact with the certification authorities. So they have to be the ones understanding what you're doing. They should appreciate the cost savings of what you're doing. And that you're not putting at any risk on the safety levels. Let's say that's for aerospace very key. I think once you're able to do that with a lot of effort, then you start, let's say, converging to a good direction, in a good direction of implementing with success. And but that's how I think I did it. It was really hard to do this. This is harder for me, at least, to do this level of positive convincing, let's say, and political negotiation than the technical part. I think the technical part, usually it's easier than that other part, I would say.
That's what we're trained to do, right? And then what are the biggest skills you took from Embraer and are now grateful you learned?
Oh, that's a good question. That's hard to categorize, but I think the general... This general perspective of what can be implemented and how it should be implemented, also negotiation skills. I think these are, and also the technical skills, of course. I think these are the things I can transport from industry to my current position in academia, I would say.
Good. And then also talking about transferring, you transferred from South America to Europe. What was that like?
Oh yeah, that's so in South America. I come from Brazil, São Paulo state. And in São Paulo state is quite large already, but within the São Paulo state, I lived in the valley between São Paulo and Rio. It's called Vale do Paraíba. It's like a Paraíba River Valley, and it's quite a bit of countryside style. I live close to the mountains, the rivers, and it was quite a nice nature and relaxed environment. So the people there, they are not really ambitious, let's say, to really strive in work. People are more relaxed. That's let's say my hometown. Let's call it like this. And people are quite open, warm. And when I moved from there to São José dos Campos, it was already a bit of a shock. Like people are more work-related, work-focused, and this is very close. And this is 230 kilometers apart. No, sorry. This is 140 kilometers apart.
Right.
Yeah. And then to São Paulo is 200 something. And, so then São José was more work focused. Then I was a bit already shocked. Then when I moved to Germany in 2012, this was a real shock. Like people were basically humorless. Sorry, Germans, but I lived close to Hamburg and the northern region of Germany in Stade. Mostly, I think the majority of the population there is already elderly people. So they're very serious, and I took part of it's called the Toastmasters. This is like a English speaking group, and then you have to. One of the tasks that we had in our meetings was to do some improvisation jokes, and wow, I was always really disappointed with my ability to make them laugh, But these were Germans basically. So it was really hard, and I had to learn German because I was living in the first 2 years with an elderly lady that rented the rooms for students, and she couldn't communicate in English. So I was really forced to learn German to some extent. I think when I left there in 2014, I had the B1 level, and it was a big shock, really. But I think coming to the Netherlands, then 2012 to 14, I lived in Germany. 15, I moved back to São José to work again, to continue my work at Embraer, until March 2018, and then I moved to Delft in June 2018.
Okay.
I think the shock moving to the Netherlands was way lower than moving to Germany in the first time, for many reasons. I think the first is that I already had that experience. The second was, I think people here, they are more open than
I agree.
in general than the Germans. Probably not in every region in the Netherlands, but I think in Delft, these surrounding areas, So I think the Hanstad, indeed, region, I think they're more open. They're more used to foreigners.
Yeah.
So it was a bit of a shock, And now we see this movement, more right-wing parties and so on. This concerns me a little bit. Yeah, but I'm not feeling any risks so far,
So you were in Embraer, you came here to Europe, you described the social aspects of moving. What about the technical aspects? Embraer is an outlier. They're successful when there's hundreds of people, hundreds of companies who are we've left on the path to being a big aerospace company. Is there a lot of differences in the workplace environment?
Yes. At Embraer, they have because they had a historical event that really made them change their mindset. They had this, I forgot the name of the airplane. It was a very modern airplane. We can look it up later. That was the last airplane developed while the company was still public.
Okay.
And the development cost was so high that it almost bankrupted the company. So they had to fire a lot of people at the time. That was in the 90s. And then they basically became a private company after this event, and they were able to restructure their mindset, their culture value, their cultural values. And then the next product they developed was the Embraer 145.
Yeah.
This is a very famous regional plane nowadays. But during these developments, they really, I think that was the first one they set their flag of who the new Embraer company wants to be. And then they went for the E-jets. They had the E1 family, the E2 family. They are still very successful. Recently, they had many new orders, I think, for the E2 family. But I think Embraer learned to work efficiently. So I can say with a relatively small engineering body, I think at the time I was there, they had about 4,000 engineers. They were able to deliver a lot and not count on government money. So they were never saved by the government or these kind of things. We know this happens a lot.
Yeah.
And I think that's how they managed to remain competitive in the market.
Do you think that it's also the more conservative mindset? Embraer well, they still haven't released, for example, like electric ideas, or Embraer plays are normally more traditional.
Yes.
Do you think that's molded you into having this more conservative view in the industry?
I think so too. I think so. I agree with you, because then even like when I look at materials into the airplane, they still don't have a composite wing, you know,
Yeah,
in the main airplanes.
Metal.
It's metal, and then the cost of developing, certifying this is so high. I would agree with you that might be related with their conservative mindset. So the airplanes, they're doing more incremental. They're optimum for what they're proposed to do.
Yeah.
But in terms of technology disruptiveness, they're not disrupting technology. I think they are more traditional. I would agree with you. But they are quite optimal. This I can say as well.
Yeah.
I think they are optimized for what they do. They can be very competitive. And I think that's how they're also successful. They deliver high performance with the robustness to the customers. So I don't want to sell. Of course, I'm biased towards Embraer, but I know their culture is quite strong in that sense. Yeah, I'm pretty sure.
And so then you talked about in 2018, you moved here. What prompted that move? What made you want to go into academia?
Oh, that's a good question. Yeah. After my PhD, I was so that by the end of my PhD, I was really passionate about research, and I was working as much as I could really in research, even doing new studies at home and all things like that. When I came back to Brazil in 2015, I was already married for 1 year with my wife, Kelly. And after moving back to Brazil, I started again my routine at Embraer. And in the evenings and weekends, I was doing research, basically. I was doing for me, but in a postdoc together with ITA. I had a professor there, Mauricio Donadon, and we were collaborating, just doing like free research. And then I must say, at some point, my wife came to me, you have to decide, you know. You cannot do both. You cannot work in industry and do the research at the same time. You cannot work like evenings and weekends. That's not right, you know. Yeah. I think it was a good conversation we had. And then I think she was right, I must say. And then I had to decide. Either I continue in industry and I drop research, because you cannot do both. You don't have time for both. Or I try to go into an academic career. And in 2017, ITA was opening like assistant professor positions there as well, you know. And then I started to study because they have an exam, like an entry exam. And then if you pass the exam, they interview you for the position. They check your CV, but the exam is the first gate to get in.
A big filter.
Yeah. I don't know if they have many applicants, because it's so specific, you know, and it's also public university there. The salary is not as high as in industry. So a lot of the qualified people, they are in industry. They don't want to come back, let's put it like this. But then I was studying for this. And then I had to get, as one requirement for the application, I had to get recommendation letters for my application. And then I was talking to my colleagues in Europe, which I had worked during my PhD, during the Desicos project. And then one of them told me, oh, there is a position in Delft. Yeah, that is really close to your CV. Why don't you check it out? You know. Then they sent me the link, and then I checked it out, and then I talked to my wife. Well, you know what? Look at this, you know. And then she literally cried because she did not want to leave abroad. You know.
Really?
Yes. And then I said, but the chances are really small. Come on, let me try. And then she kind of said, okay, go ahead, you know. But she really did not want to leave abroad, I must say. I think she still doesn't like too much abroad, but because of the kids and so on, we can discuss that later. I think she's changing her mind now. But just to say, that was kind of the very pragmatic reason why I had to choose academia, because I couldn't do both anymore. And then I ended up in Delft because I applied for both. But the answer in Delft came earlier, that I was accepted, and then I decided to try Delft, believing that if I wanted to go back to Brazil, let's say it would be easier than otherwise, than starting in Brazil and then moving abroad later. Yeah. So that was my reasoning at the time.
But when you finished your work in Germany and you came back to Brazil, didn't you have like any feeling of, I don't know, being in Europe, like being so much more advanced, like knowledge community?
First world country versus third world country.
Weren't you like hit by that?
Oh yes, yeah. I remember well in Brazil, in the first month after coming back from Germany, I had more headaches with companies like internet companies and so on,
Yeah.
than what I had in Germany for
Yeah.
3 years, you know.
Yeah.
I must say, Germany and Netherlands, they're so organized,
Yes.
and that when you go back to a third world country,
It's hard. It's hard.
then you really understand why it is a third
Third
world
world
country.
country.
Yeah.
Yeah.
I think for you guys, you
Yeah,
can share
we
that.
understand.
And I think, to be honest, it's more a mindset of the whole population than just like if you change one politic, like the
Yeah.
president, it doesn't solve the problem
Mhm.
because it's a deep cultural,
Cultural,
problem,
exactly.
in my
Yeah.
opinion.
No, I
and
agree.
then that's really hard to change. And then you become a bit of the how to say, the exception, you know.
Yeah. Oh, I lived in Europe.
But
yeah,
you cannot judge too much. I think when you go back, you need to go back fully. You know, that's what I tried to do in 2015, and try to embrace again. You know, the opportunities you had. That's what I did. I think I did it well. But now when I visit Brazil, I still struggle with this.
Yeah.
For a few days at least.
And you talked about the balance between when you're working in industry and you want to do the research on the weekends, and now there's parallels in your life when you're teaching
Yeah.
first years, mentoring your master's students, and doing your research.
Yeah.
What's that balance like?
Yeah, that at the beginning was a hard balance to find, I think, because I felt I was a bit overwhelmed with teaching the first year that I was teaching, because I think that happens with everybody. Then I realized that, but I felt, wow, I'm just teaching now. I felt a bit stuck. Okay, with my research now, I cannot really develop the direction I want to develop. But I think it was just I was learning the academic environment really. It was not the case, I think. It was really the normal path. If you start teaching a new course, in my case, it's dynamics. When I started here, you have to prepare a lot, and that preparation takes a lot of time. That was it, I think. And then for everyone going to teach a new major course like this, you can expect, I would say, 500 hours of preparation, and then you need to account for that in your planning. So that of course, that will sacrifice other things, But I think the balance is quite good now. Usually we consider a good balance around 50-50, 50% teaching and also, let's say, supervision of students, and the other 50% working with the PhDs and proposals and postdocs, and also conference, all the research aspect.
Right.
But I think it's quite a good balance of 50-50 approximately.
And more recently, you've done some pretty specific research on crashworthiness with bird strikes and then now hydrogen. What are some of the more important findings you found, if we want to get technical just for a second?
Yeah, I think because we are in the conventional airplanes, especially for the conventional airplanes, we do have to evaluate them for crashworthiness, at least to check if they are crashworthy. What I learned with some of the designs, like the Flying V was a very interesting case, because they have this oval fuselage. And if you look underneath the cabin floor, there is significantly less space, what we call crushing space, than if you compare with the A350, which is their competitor. And then immediately, when we had some students working on that, Marco Desiderio and more recently Tiago Ferreira, both investigated the Flying V, and both concluded that the dynamic response index, which is related with spinal injury of a passenger, it is not low enough for the Flying V.
Wow.
So if we would like to certify a design like that, we would need to work a lot on the structural design, but not in the way we do with the conventional airplanes, because we size basically for airworthiness, for the flight loads, and then we check for crashworthiness. But now the big change is that in the design cycle, you need to design not only for airworthiness, but also for crashworthiness.
Right.
And this requires a lot of technological development to allow that.
Okay.
Because even, to give an example, the crashworthiness models, they're quite detailed. I don't know if you've seen them, but they're usually already like 3D models, very detailed.
Lots of matrices.
Yeah. And with for the airworthiness analyses, you can do a lot with simplified models. And now one of my research topics is how to bring or to develop simplified models that we can use also during the product development, the early phases, to already assess crashworthiness. So that's one of the things that I learned with that's related with crashworthiness in my research. And for bird strike is a similar problem, by the way. Yeah.
And so then a lot of people think that hydrogen power is the future of aviation. You've worked with hydrogen crashworthiness, to be exact. What do you think, given your research?
Yeah, that's a good question. I think hydrogen can be a future fuel for aviation and for other things.
Battery or combustion?
Yeah, what I see more is people are going more for the fuel cell option, but they say if you go for longer range airplanes, that the burning option also becomes very interesting. The problem with the fuel cell is the amount of heat that it generates, so the thermodynamic cycle is not as good apparently. But I don't know exactly the trade-off. I think for this I have other colleagues they can really explain it well. But I know that there is this boundary basically after a given size of airplane, then you don't use fuel cells anymore. You use direct burning of hydrogen.
Right.
But for both cases, you need to store hydrogen somewhere in the airplane. And hydrogen if it's a cryogenic liquid state, with stored at around 10 bars pressure, it occupies 4 times as much volume as kerosene. And you need this cylindrical type of vessels.
Protected from...
So then that means it will be in the fuselage somewhere.
Right.
Usually, you can also try other places, but the most conventional studies you see, it goes into the fuselage, and then that makes the airplane
smaller.
The fuselage must be bigger or wider, more like bulgier, let's say. And the crashworthiness again has a direct impact not only on the safety of the airplane, but now in the performance of the airplane, because we have an honor student, Maurice Hoogreef, Peter Jan Proesmans, and me. We have an honor student working on the effect of crashworthiness on the performance of the hydrogen-powered airplanes. And you can see it is enormous. So if you cannot use the whole fuselage to store hydrogen if you consider crashworthiness. And then we notice, of course, if the amount of volume that you can effectively use is smaller, then you're always penalizing the airplane. So just to say, the hydrogen-powered airplanes, if hydrogen is the fuel of the future, they will be less efficient than the kerosene ones. And then we need to assume that hydrogen will be green hydrogen, right?
Yeah.
So that's the big assumption that I don't know if it's aligned with the energy supplies that we have today. So yeah.
And in comparison to sustainable aviation fuel,
biofuels,
the biofuels.
Do you think that would be a more realistic alternative
compared to biofuels, for example?
Or hydrogen compared to biofuels?
Biofuels, I did a comparison when I was writing my vision for the tenor track. When I was a tenor tracker, the amount of biofuels you would need would be equivalent to, I think, 4 times the area of Germany in like sugar cane,
Wow.
But I have the exact numbers. I would like to check them later, but it's just a really big area you would need in sugar cane just to supply alcohol, let's say, for aviation. Because these numbers we have very accurately in Brazil because we produce a lot of alcohol. Then I was able to check, okay, for aviation, how much area would we need? It's really extremely a lot. So I think biofuels, they are not an option. And then you would compete with food supplies.
Yeah.
Like unavoidably, you would compete with food supplies, and that creates like so much problems. I don't know if it's
ethical
a good
problem too.
Yeah, ethical problem. So I don't know if it's a good option. I think that's probably not the right way to go. And then they have this SAF, sustainable air fuel. I don't know enough to say about SAF. And also they have, I think the good one is the e-kerosene. They say they can synthesize kerosene with a high energy cost. But if that's doable and if energy is abundant enough, I think that would also be a good option.
Okay. And then you spoke about it at the beginning, and it's becoming more and more apparent now, but your research really is practically oriented. And, you have your students doing these things that are directly applicable to industry. What advice would you give to master's students or PhD students just starting out that are looking for that want to do research, but that relates to the real world really well?
Yeah, I think for the master students, they have more freedom to choose because usually a PhD is linked to a project and that was already written. And I think they are more attached to some, they already have a good case, I think, the PhD. Especially here, I see to get a PhD proposal funded, you need to have a very good proposal. I really believe that here, the most of the PhD projects, they already have a good link with societal impact. But for the masters, my advice is ask your supervisors when we are choosing a topic, what is the what is the potential applicability of the topic? Because usually the supervisors, they have this idea. They have this idea really well. If they don't, they usually talk to the right people to contextualize a bit better. I have also I have a website, and there I have one small page like tips for your master's students.
Yeah.
And one of the things is how to choose your topic, and this I think it's a good it's kind of a good list of things you can try to do to understand the topic a bit better, to choose your topic a bit better. And I think it's the goal is always that you choose the right topic for you, and I think being applicable, it only creates more motivation. Yeah.
Okay.
Do you think that Delft does it differently? You talked about how in Brazil, or I guess also applicable to Latin America and also a bit in the US, it's a lot more theoretical. Here, students, master students and PhD students, they can actively test their research.
Yeah.
Do you think that puts a big impact into how these technologies are going to be applied very soon in the future?
I think so. I think our students, they have a big differential with respect to the other places I worked and I was in contact with, is that they really know how to design something under uncertainties. I think this is a big differential of our students. And I think that relates to creating a product, and not only creating a theory, but really creating something and finding use for it. I think this is a very good strength of our students. So I think that, yes, to answer your question, I think yes, we are different in a positive way. I would say, yeah.
And then now, just talking about research and things that are positive, what's your take on AI, especially when it comes to your research and how it could play a role?
When ChatGPT came out, the 3.5 version, 2 years ago, more or less, a bit more than 2 years ago, they ran a survey within TU Delft. The exact number of the researchers, you can look it up. But they sent to a lot of professors questions. So can you please submit one bachelor's level question, one master's level question, and one open research question, which would be more a PhD level question. And check how well GPT will answer. I must say I was not interested in GPT up to this survey. I submitted one of my dynamics final exam questions. I submitted one question from a master's level, from stability of structures, and an open research question. In the bachelor's question, it aced. It gave a perfect answer. And the master's question also gave a very good answer. It would have gotten 8.59. Yeah. And in the PhD level, it was a big disaster, I think. Yeah. But then I started paying attention to this, Now we are in the 03 version. I think it's the latest version of ChatGPT. Yeah. I made a test with the most recent 03 version using deep research, it's called. I was impressed. It did an extremely good job in finding information. For example, I had a manuscript we were about to submit, and there was a number we used. This came from one of the master students, and we used a number of 0.1 for the exploration in the Bayesian optimization, And then I wanted to get some literature justification for what are we using this number, and then I used this deep research, and it found like extremely well the references, and not only that, it kind of gave the excerpts of the text of each reference that I could use directly. Wow. To justify the number, and they were all correct. So the hallucination problem that we had 2 years ago, apparently they have resolved it. I haven't tried like extremely well, let's say, to evaluate if it's still hallucinating, but I think they have improved a lot. I was checking yesterday that 80% of the web traffic now is due to AI bots.
Really?
Yeah, in the world. So that means people are not looking up things anymore. Like they don't go to Google and they search something. They go to ChatGPT, and the ChatGPT will spoil this bots to get the information, and then you already get the information post-processed, But this is 80%, and only ChatGPT is 13% of all the web traffic. That's incredibly high, And then, so just to answer, this is changing already how people are looking for information, that based on this evidence. And I think in the future, it will change even how we perform our work in a more like implementation sense. Because, for example, I'm a passionate programmer. I love Stack Overflow. I don't know if you know about it.
Yeah, we know.
But I have a very good profile there when I was doing my PhD, I was like answering questions. I answered more than 600 questions, even I think 700 questions. The impact is like 4.5 million people reached. It's really high. But now, if you look at my reputation, everything over time, after GPT came, it's almost stagnated. That means people are not using Stack Overflow. Even hobbyist coders like me, we are not coding anymore, because if you try with GPT, you can try with any large language model. It will give you a code that it would take you hours, if not days, to produce in minutes, you know. And then that's changing how people work. So now you need to know, like, I have this agent all the time, you know, at my disposal. I need to learn how to work with this agent. And this is changing how people work. And I fear, you know, I'm pretty sure even how we write, it will change, because now we consider writing a very important skill. But if you look at the quality of the text it's producing and the short time it takes to explore an extremely high amount of information, you know, and synthesize, I think it will change also how people write, which is very concerning. Because I still don't feel prepared for this. But seeing how I changed my coding perspective, I can also see how people will change their writing perspective.
So you're a professor, you're a researcher. You look at all these advantages of ChatGPT, of AI, but you look at regulators, you look at people who are making planes, people who your research is going to be applied to, and they're a bit more skeptical. How do you think that this skepticism will be overcome to apply AI in aviation?
Wow. That depends what to call apply AI in aviation. Because I think if it's to produce reports, to produce images, or to help you synthesizing information that you already have, I think this is great. It's a great tool for this. It's like a good agent, really, that you can use. But if you are talking about these machine learned models, let's say to calculate structures, and you can train a machine learning model to calculate a structure, I think they're very good in interpolating. But as soon as you go outside the design space for which these tools have been trained, I really think they struggle a lot. I don't know if this will change. Then I think using AI to calculate things, it will be really hard to get accepted and without a very good verification validation campaign. But I think it can be used to give you optimal solutions. I think for this we're already doing. So if one of my master students, she's now doing the PhD, Ioana Ciobotia, she managed to include in the design of wing boxes one of the constraints from bird strike. So the constraint was that after a bird strike, there could be a maximum penetration of 100 millimeters. I don't know the exact number, but there was an exact amount of deformation that we established as maximum. And then we wanted the lightest wing that would produce that deformation. And then it would still sustain the flight loads. And then she managed to optimize that. But the optimization tool requires such machine learning models. And then it gives you an optimum, but then you need to, most likely in an industrial setup, you would take that design, you would detail, you would eventually test it. If you have these other steps, I think it's fine to have the AI to help you to reach the design. But then the further qualification that is required, I think it will still be there. But how fast you get to that qualification point, I think that's how AI will help a lot.
Okay. And as an educator, how do you see AI playing a role in how you teach your students?
Yeah, I think that part, I don't see AI replacing us, like in the lecture room and so on. But for example, I see AI as a tool, as a teacher now, it can help me create animations and things to illustrate what I want to talk about. Even we are doing this we are investigating this within the masters. We have a group of composite design. And one of my colleagues, he prepared, Professor Christos Kassapoglou, he prepared a treasure hunt adventure for students. And then there were very nice images and so on. Then we took one of the images, and if the student failed that assignment, the student would fall into the river. You know, that was the idea. And then I used the Sora to create a small animation based on his picture. And then I took his picture, created a movie out of the picture with the student falling into the water, running with the computer, you know. That was incredible. I think it can really help us to illustrate and to make things more attractive to the students. but I don't see AI replacing the lecturer in the lecture room. I don't see that. I think I don't see yet that risk. I might be wrong now, but I think we are still irreplaceable facilitators for your learning. But then now if I ask you an assignment, very, very complicated one, I think you will be able to deliver that very soon with AI.
Mm-hmm.
Okay.
But again, if we go for a written exam, then AI will not help the students. I think that's why. But I think written assignments, they will become extremely more complicated, sophisticated because of the tools allowing that. So even you can optimize faster, you can do everything faster because of the AI. Let's say the level of detail that you're going to achieve within the projects and so on, it will be really much higher, I think, because of all these tools, including AI.
In the sense that AI is going to be an assistant now, it's going to, instead of replace us, it's going to be a tool for us. So in the future, do you think that AI is going to become the same way as the calculator was at its time? That now things are designed to be done with calculator?
Yes, I fully, I'm with you on that. I think, because I saw the transition from a few technologies, let's say even like a normal calculator to the graphic calculators, and then to computers. Everyone has a laptop, and then you just see, okay, now I don't need a calculator anymore. I just have Python here, whatever, and I can do everything with Python. Not as students, you need a calculator, but after you will drop it completely, I think. And then the AI is just I see as a better agent. Yeah, because now we used a lot of Google to search things. This is already proven that 80% of the traffic is already AI bots. So that is already proven that people are looking things up more with AI than with Google. So this already changed, but I think it will change even more. It will become more accepted. I think it will even be more accepted for writing.
Right.
Okay.
And so you talked about AI with regards to being a researcher, being an educator, and then what about in industry? Is it the same view, more or less?
So, like, for example, in industry, can I write a certification report using AI?
Yeah.
I would say no, but how can you control that? How can you know that a text was written by AI? If you give you an example text that you wrote, and you say, use my style, but now write this, it will be your style, or very close to your style. And that I see like the tools are so good that it's almost impossible to distinguish between human written text from AI written text. And 2 years ago, that was not the case.
Yeah.
Right.
So do you think that now there's going to be a big more emphasis in practicality or real world tests? Now that for the theoretical, we can use AI, which we can trust, but can we really trust it?
Yeah, but I think it works as an agent, but it's not creative. So you can test new ideas, you can prototype new ideas very quickly. And to make sure that the prototyping process is correct, you need to understand what you're doing. So you need to understand all the steps that you are asking the AI to take. But taking the steps is what is very fast. You know what I mean? So you know which steps they have to be taken. Like, for example, I have an idea of a research. Even I had an idea recently of a research of using shell-based lattice structures and how to calculate linear buckling for them.
Okay.
I had this idea. I used AI to say, okay, can you prototype a quick code here to calculate the strengths at different integration points? It did it in I don't know 10 minutes. Yeah. After a few back and forth, but this with the master student could have taken 2 weeks, let's say. So you see, if the master student knew how to interact with the AI, he or she would have gotten to the same result in a few minutes that normally would have taken 2 weeks, let's say. Just to give you an example it will help you taking that step faster, but you need to know what you're doing. You need to understand the overall goal that you want to achieve. And in the creativity part, I think it's still on the human side, which is great. I think we should keep that way. But I think just taking the steps will be extremely faster in the future. The prototyping aspect will be much faster. Okay. And if you can link AI to manufacturing, even like making parts will be faster, not just visually, but then physically. You can really make something up if you can make this connection happen.
Yeah, and efficiency as well, I'd imagine. Also, what do you think are some of the biggest obstacles, challenges, problems that are going to come up in aerospace, in the industry, in research in the next 10, 15 years that we're going to have to confront?
If you asked this question 2 months ago, I would say sustainability.
But
but now we had Trump, and all this conversation about defense. I can see sustainability. It became a bit suddenly a second
Priority.
I think, and there will be a lot going on with defense. I think so. But what is the main challenge for us in aviation? Yeah, the sustainability aspects. Despite it has become second plane, but if I think about just aviation, like civil aviation, I think it will be still very, very much constrained in terms of ticket price because of CO2 footprint. So either we shrink the industry, which nobody wants. Like as technical people, usually we are against shrinking economy and stopping producing airplanes and stopping flying. We really want more to make the technology more sustainable to allow us to keep flying, but in a more sustainable way. But I would say if we don't achieve that sustainable way of flying, there is a risk, of course, for the industry, because then it will become too expensive to fly, for example, and then because of the offer-demand balance, it will naturally shrink.
What about protectionism? Trump talked about, well, I guess everyone knows who's watching the podcast how for example, with the Boeing F-47, they're planning on making different models for the Americans and different models for NATO allies.
Wow!
Because you don't know if they're going to be your allies anymore.
Wow!
Do you think when you were in the industry, do you have any experiences of like, whoa, okay, these guys are Brazilian, I don't know if we can trust them, or these guys are Chinese, we can't share this information with them?
I do not have that experience directly, because I never worked in the military programs directly, but I know they exist. Yeah, I know they exist. I'm pretty sure they will exist. Always they will exist to some extent, but that's how that would be my short answer to that. I think these are things that will make not the civil aviation sector worse, but it will make the world peace problem much worse, I think, in the next years. I see that happening, I think. And unfortunately, that's how I see that. Yeah.
And how does AI play into that? More or less, from what I've understood, you seem to be very hopeful about AI and its applications. How do you see it helping us in the future?
So I think if you should learn, so again, going to the basics, I was explaining earlier, when I was doing my bachelor's, I did not have the perspective I have today of the importance of the different things I was learning. So just make sure that to learn the basics now, because if it comes the point you need to interact with a very advanced AI tool in 10 years, that you know what you're doing, so you can guide the AI, and you will not trust the AI to guide you. You know, so because the questions you should never ask the AI is, what should I do? With my life, kind of. No, you should know what to do with your life, and then to achieve that faster, you can use AI. I think, but not the other way around. We should be the ones controlling them. Yeah.
And then finally, what personal legacy do you want to leave behind in the field of aerospace? And what message do you want to leave the younger generation of engineers following in your footsteps? Okay,
so I think in terms of research, I really want to revolutionize the design of airplanes in a way, either producing revolutionary designs or with methodologies that would allow revolutionary designs. And then I work in two fronts. One, you already mentioned crashworthiness, but the second front is also exploiting all the strength of existing materials even. Because, for example, if you have a design that is constrained by buckling, that means it's constrained by stiffness.
Right.
But if you look at what happens after buckling, then you reach the material strength, and then you start fracturing the structure and so on. You see the cracks and all the things that happen after that. So I think we should design. There is a lot of margin, I think, if we, for example, enable buckling to some extent, and then we allow all the structure to fail, or let's say driven by the strength of the materials, and then we can also focus on improving the strength of the materials, and that would have an effect on the final weight of the structure. So I think that would be my legacy on the research. And on the message to the students is that, especially I will focus on the engineering students. Yeah. So engineering is not an easy course. That's the first message. And if you got here, I think I always say that also in the first dynamics lecture, it's not easy. It's not supposed to be easy. I think the things we deal with are hard things to learn. But especially in our faculty, to get here, you already went through quite a hard filter, you know. So I think you are already probably you're above average in terms of technical knowledge and technical potential. So then you can put this trust in yourself, you know. So I have this potential. And if you don't feel like you're catching up with things, look again at your routine, you know. Look again if you're being really disciplined, if you're trying hard to, let's say, wake up early, be there, you know, and try hard to learn every day without exception. Make sure you're up to that commitment, let's say, and also look at your habits during your free time. Because despite you say, this is my free time, I do whatever I want, but this premise that what you do in the free time will not affect your working time, it does affect. So make sure that what you do in the free time does not mess up too much with what you do in your working time. I think that would be my piece of advice.
Okay.
Thank you very much. That's Professor Castro, everyone. Thank you for your time.
Yeah, thank you for the interview. It was a pleasure talking to you.
Hi, I hope you enjoyed the podcast. I have a message from the team at Aerovia. Make sure to check out our platform where we unify aerospace courses, resources, and communities. We also have aerospace merch at shop.aerovia.org. Also check out our links in the description for our socials. Stay tuned for more aerospace content.